space, the final frontier. Or so we thought. Turns out there's something even more mysterious and mind-boggling than the vast expanse of the cosmos, time itself. We experience it every day, every second, every minute, every hour that ticks by. But what is it really? What are its true nature and properties? For centuries, physicists have grappled with these questions, trying to pin down the elusive essence of time. We've made incredible strides in understanding the universe, from the smallest subatomic particles to the largest galaxies. Yet time remains one of the most profound enigmas in science. Think about how we usually describe physical systems. We talk about their energy, their temperature, their entropy. These are all properties that tell us something about the system's state at a particular moment in time. But what about time itself? Can it have properties too? Traditional physics treats time as a constant, a backdrop against which the events of the universe unfold. It's like a river flowing at a steady pace, carrying everything along with it. But what if time isn't so simple? What if it can speed up, slow down, or even loop back on itself? This is where things start to get really interesting. Einstein's theory of relativity already showed us that time is not absolute. It can be warped by gravity, meaning that time flows differently depending on where you are in the universe. But time crystals take this weirdness to a whole new level. They suggest that time itself can have a structure, a repeating pattern that breaks the usual rules of physics. This is a radical departure from our classical understanding of the universe. We all learn about the states of matter in school: solid, liquid, gas, and plasma. Each state has its own unique properties that arise from how its atoms are arranged and how they move. But time crystals introduce a whole new dimension to this picture. Time crystals are not defined by their physical form, but by their behavior in time. Imagine a pendulum swinging back and forth. A normal pendulum will eventually slow down and come to a stop due to friction. But a time crystal is like a pendulum that never stops swinging. In a time crystal, atoms are constantly switching between different configurations, repeating the same pattern over and over again. But here's the kicker. They do this without any external energy input. It's like a clock that runs forever without needing batteries. This seemingly impossible behavior is possible because time crystals are not in a state of equilibrium. They are constantly evolving, yet their overall structure remains the same. This is a fundamentally new way for matter to exist, and it has profound implications for our understanding of the universe. Think about a cup of coffee. You pour it hot, and over time, it cools down until it reaches the same temperature as the surrounding air. This is called thermal equilibrium, a state where everything is balanced and there's no net flow of energy. Most of the physical systems we encounter in our daily lives are in equilibrium, or at least close to it. That's why it's so strange to think about something like a time crystal, which is constantly changing yet never settling down. Time crystals exist in a state known as non-equilibrium. This means that they are constantly exchanging energy with their surroundings, but they do so in a way that maintains their internal structure. They are like a whirlpool in a river, constantly swirling and churning, yet always maintaining its distinct form. This ability to exist outside of equilibrium is what makes time crystals so groundbreaking. It opens up a whole new realm of possibilities for understanding the universe, from the behavior of exotic particles to the evolution of the cosmos itself. Section 5, Quantum Weirdness, where time gets fuzzy. To truly grasp the strangeness of time crystals, we need to delve into the realm of quantum mechanics. This is the theory that governs the behavior of matter at the atomic and subatomic levels, and it's chock full of mind-bending concepts. One of the key principles of quantum mechanics is that particles can exist in multiple states at once, known as superposition. It's like a coin spinning in the air. It's both heads and tails until you stop it and observe it. This fuzziness extends to time as well. In the quantum world, time is not a straight line. It's more like a branching path with multiple possibilities existing simultaneously. Time crystals take advantage of this quantum weirdness. They exploit the superposition of states to create their repeating patterns in time. It's like the time crystal is flipping a coin over and over again, but instead of landing on heads or tails, it exists in both states at once. This interplay between time crystals and quantum mechanics is still not fully understood, but it's clear that we're only just beginning to scratch the surface of what these strange objects can teach us about the nature of reality. Section 6, the birth of a time crystal. How do you even create a time crystal? It sounds like something straight out of science fiction, but the reality is just as mind-blowing. The first time crystals were created in the lab using ultra-cold atoms trapped by lasers. Picture a group of atoms cooled down to almost absolute zero, the lowest possible temperature imaginable. At these frigid temperatures, atoms barely move, and their quantum properties become much more pronounced. By using precisely tuned lasers, scientists can trap these atoms and manipulate their spin, a fundamental quantum property. By applying a specific sequence of pulses, they can nudge the atoms into a repeating pattern that extends through time. Voila, a time crystal is born. The creation of time crystals in the lab was a major breakthrough, proving that these bizarre objects weren't just theoretical constructs. It opened the floodgates for further research and sparked a wave of excitement in the scientific community. Section 7, the potential applications of time crystals. Time crystals are not just a fascinating scientific curiosity. Their unique properties have the potential to revolutionize various fields, from computing to navigation. One of the most promising applications of time crystals lies in the realm of quantum computing. Quantum computers harness the power of superposition and other quantum phenomena to perform calculations that are impossible for even the most powerful classical computing. Time crystals could be used to create more stable and robust qubits, the building blocks of quantum information. Their ability to maintain coherence over long periods could lead to significant advancements in quantum computing, unlocking solutions to some of the world's most complex problems. Another potential application is in the field of ultra-precise timekeeping. Atomic clocks, the current gold standard for timekeeping, are incredibly accurate. But time crystals could potentially surpass even their precision. Imagine a clock so accurate that it wouldn't lose a second over the entire age of the universe. Such a timekeeper would have profound implications for navigation, communication, and our fundamental understanding of the cosmos. Section 8, peering into the future of time. The discovery of time crystals is still in its infancy. It's like we've stumbled upon a hidden door in the universe, and we're only just beginning to peek inside. What secrets do these strange objects hold? What else can they teach us about the nature of time itself? Some scientists believe that time crystals could provide insights into the mysteries of the early universe. The extreme conditions of the Big Bang, where energy and matter were unimaginably dense, might have been the perfect breeding ground for time crystals. Others speculate that time crystals could be connected to dark matter, the mysterious substance that makes up the vast majority of the universe's mass. Could time crystals be the key to unlocking the secrets of this elusive cosmic component? These are just a few of the tantalizing questions that lie ahead. The study of time crystals is a journey into the unknown, a testament to the boundless capacity of the human mind to explore the universe and unravel its most profound mysteries. Section 9, conclusion, a universe full of surprises. The universe is a strange and wonderful place, full of surprises that defy our intuition. Time crystals are a perfect example of this, challenging our very notion of what's possible and pushing the boundaries of human understanding. The discovery of time crystals is a testament to the power of human curiosity and our relentless pursuit of knowledge. It reminds us that the universe is full of wonders waiting to be uncovered, and that the most mind-blowing discoveries are often the ones we least expect. As we continue to explore the properties and implications of time crystals, we are embarking on a journey into the heart of time itself. Who knows what other secrets the universe holds, waiting for us to unlock them. Don't forget to like the video, subscribe to my channel, and leave a comment. Thanks for watching.